Hey everybody, this is Miss Eisencraft with Unit 6, Lesson 2, Practice Problem Help. Okay, we have assigned numbers 1, 2, 3, and 6. Let's see what page that's on. I printed these off, so they don't have the page numbers. It would be in my book, which should be the same as your book. Page 19 through 21 in the Unit 6 through 7 book. Yes. Okay. 19, 20. Yep, here we go. All right, first one. How many small squares are in step 10? So we're just counting squares. So step 1 has 2. Step 2, 6. Step 3, 3, 6, 9, 12. Okay, no nice linear pattern, no multiplying pattern. So I'm going to try to determine, and there's a different, all of our eyes kind of see this a little bit different, but if you can help see the step number in the picture, sometimes that will help you kind of see the pattern and then like zoom out to step 10 without having to draw each one. Step 2, I see a 2 by 2 square. And then 2 more. Step 3, I see a 3 by 3 square. And then 3 more. So why that will help me is if I say, do I see this number in the picture? I can zoom out and say, okay, step 10 would have a 10 by 10 grid right here, right? A 10 by 10 grid. And then one more row of 10. Another row of 10 right here. Okay, so that'd be 110 more. Because this had a 3 by 3, 9, plus 3 more. 2 by 2, 4, plus 2 more, 6. So I see 110. I want to be clear, there are other ways to see that or explain it, but you still would land on 110. And that's just how I chose to kind of visually see the pattern being built with these little squares. Okay, number 2. Here are 2 pattern dots. They are going to ask us to just go out to step 4. So I'm going to go like this. And I'm going to go like this. So what would step 4 look like? Some people love these and some people hate them. I get better at them the more I do them. Okay, sometimes starting at 0 is not very helpful, but if you just kind of zoom out and look, okay, we have a row of 4, 2 rows of 4, 3 rows of 4. Okay, that would make sense. 1 row of 4, 2 rows of 4, 3 rows of 4. The next one would be 4 rows of 4. If you can ever see the step number in the picture, that is helpful. So step 4, 4 rows of 4 would be 16. So the first one, A, has 16. Okay, and again, step 3 had 3 rows of 4. Step 2 had 2 rows of 4. Step 1 had 1 row of 4. And you could say step 0 had 0 rows of 4 or nothing. Pattern B is a little bit different because maybe not as easy to see. So if I can't tell what's happening here to here, I have to keep looking so I don't make assumptions. Okay, it looks like these 2 little legs, I almost look at them as like little feet. They just keep these 2 little dots. Okay, they're there in each picture. And then this part, let me actually like this. My book is making noises like it came alive. That would be a horror film, a math book that comes alive. Okay. Look at that. Okay. Now I can see things a little bit better. So in step 0, we just have these 2 dots. Step 1, I have those 2 dots plus 1. Okay. Step 2, still have the 2 dots plus 4, or maybe a 2 by 2 square. If you can describe like what's happening in the step related to the step number, you will have an easier time seeing the pattern. Step 3, it's a 3 by 3 set of dots with those 2 extra. So step 4 would be a 4 by 4 set of dots with those 2 extra, right? So there's 16, 2 more, 17, 18. Good times. All right. Next one. Which pattern shows a quadratic relationship? Well, this one went from 0 to 4 to 8 to 12 to 16. When you are adding the same amount each time, that is a linear relationship. We've studied a lot of those. Our eyes see those pretty well. So that is not quadratic. This one is not linear or does not have a multiplier, which is called exponential. It instead involves like the step number something, the step number squared. Okay. Since we had like step 3 had 3 squared plus 2 more, right? Here was the actual rule. But since it involved the step number squared, this indicates that it is a quadratic relationship. And maybe you could just say, hey, it wasn't linear. Hey, it wasn't exponential. But this n squared or this variable squared, step number squared, indicated that it was quadratic. Let's keep on going. Number 3. Okay, here are some descriptions. Okay. All right. We have pattern A, step 2 has 10 dots. It grows by 3 at each additional step. Pattern B, total number of dots. They're going to give us an equation. Okay, where for each pattern, draw a diagram of step 0 to step 3. So I'm going to go like this. Okay, step 0, step 1, step 2, step 3. Okay, this took some thinking. I had to do this ahead of time. Okay, step 2 let's do pattern A. Okay, this is pattern A up here. Okay, has 10 dots. They zoomed in here, has 10 dots. Well, do we just draw 10? What? It grows by 3 dots at each additional step. So if it grew by 3, I'm just going to draw the 3 dots here. And I'm going to say, okay, this is how much it grew by from here to here. But it has to have 10 dots. Well, from step 0 to 1, it also had to grow 3 additional dots. So I'm going to draw another 3 so that I could go backwards here. And I also know I need to have 10 dots. So right now I have 6. What if I just draw 4 more, like in this kind of pattern? Okay. All right, let me see if I can work this backwards. So far, this has 10 dots. And I need to show that it's growing by 3 every time. So if it's growing by 3 this way, let's have it decrease by 3 this way. 1, 2, 3. Dun, 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 dun. Okay. Ooh, so same thing, then it grew by 3. Can we go back? Sure. 1, 2, 3, 4, decrease by 3. Okay. And then if we go to forward, we started with these 4 dots. Maybe this is kind of like what we started with, and then we just kept adding groups of 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3. All right, good times. All right. That was A. Okay. B is completely different. B, they're giving us an expression. And whenever we get an expression, right? So think of n as like your step number. Okay. So an n squared, we've kind of talked about this, an n squared, we can think about like a 1 by 1 dot, a 2 by 2 dot, a 3 by 3 dot, a 4 by 4 dot. But this number in front says we have 2 of those plus 1. So I'm going to go to like step 2 because I think it's easier to draw it in step 2. Can you guys see okay? All right. So if I draw 2 n squareds, I'm going to draw 2 shapes that are 2 by 2 because I'm starting at step 2. So just bear with me here. This is, think of this as n squared or 2 squared. Okay. I have 2 of them. So I'll draw another one over here. And then this plus 1 always stays a plus 1. It doesn't change no matter what your step number is. I'm just going to draw it in the middle. I'm going to just draw it along here. I'll put a little, okay. So I took the step number, which I can think of as my n, and I did a 2 squared. I made like a dot pattern that was my step number squared. But since there was a 2 in front, I made 2 of them. So I did 2 squareds plus a 1. So for step 3, I'm going to make 2 3 squareds plus a 1. So I'm going to make a 3 by 3. So that's an n squared, a 3 squared. This is an n squared. And then the 1 in the middle. Okay. So I have a 3 squared, which was your step number squared, or your n squared plus 1. Your 2 squared plus 1. It's a 1 squared. 1 squared's just, there's your 1 squared, there's your 1 squared, there's your 1 in the middle. What the heck is a 0 squared? Nothing. 0 squared plus 1. 1 in the middle. Good times. Okay, now your dots could look a little bit different, but the total would look like that. That's just how I organized my thought. Maybe this dot, you put it in the center or up top or like a triangle shape, but I just put it in the middle. Okay. All right, 1, 2, 3, and number 6. Okay, number 6. This is like, ruh-roh. Catch up, ImageMate.